Okay, so this is going to be basically the 5A notes, so intro to Unit 5, which is mainly about parallelograms. And you might remember parallelograms, the way that they're defined is you have a four-sided shape, so a quadrilateral, and the term parallel is important. The top and bottom are parallel, and the left and right are parallel. So both pairs of opposite sides are each parallel. So there are going to be 5 ways in class that we use to prove parallelograms, to prove that something's a parallelogram. The first one is actually that definition that we just talked about up here. If you can prove the top and bottom are parallel and the left and right are parallel, then you get a parallelogram. So this symbol right here is used for parallelogram. So in a proof, if you had to use this idea to prove that something's a parallelogram, you can either write out everything that's written right here. Both pairs of opposite sides are parallel, then the quadrilateral is a parallelogram, or you can use like a picture notation that we'll do instead in class, which is this. Let me use black here. If you can prove that the top and the bottom are parallel and the left and the right are parallel, then you get a parallelogram. So that's one of the ways of doing it. Another way would be, now the number 1 and number 2 are almost exactly the same, except that the words change from parallel to congruent. So this one, instead of parallel arrows, I'm going to use congruent tick marks. So the left and the right side are the same, congruent, and then the top and the bottom are the same. They're congruent. Okay, the next one, now notice this one, it's the same exact thing as before, except sides turned into angles. So instead of marking opposite sides congruent, I'm going to mark opposite angles congruent. So I'll put one curve here and one curve there. And then at the same time, I'm going to put 2 curves on the other corners. Okay, the fourth one, if one pair, just one pair of opposite sides are both congruent and parallel, then you get a parallelogram. So that one would look like this. One pair of opposite sides are both congruent and parallel. Right? So it turns out that one you don't even need to look at the other sides. That's enough. And then the last one deals with the diagonals. So we're going to have to draw in the diagonals here. And it turns out if the diagonals bisect each other, so if they cut each other in half, so this little part would equal this little part, and then this little part here would equal that little part there. If that happens, then you get a parallelogram. Okay. So those are the ways to get a parallelogram. And then sometimes in a proof, you have a parallelogram already. You're not just proving that they exist. You're proving stuff from parallelograms. So if you already have one, it turns out that these 5 things up here all work the other way too. And they match up with 6 through 10 down here. So one of them would be, if you have a parallelogram, then both pairs of opposite sides are parallel. So that's this. Which if you look up above, that's the exact opposite of what we wrote up here. The second one, same deal, right? I'm just going to reverse them. So you would know that opposite sides are congruent if you have a parallelogram. Or opposite angles would be congruent in a parallelogram. So 2 and 2, 1 and 1. Or this one is kind of overkill, I suppose, because you could combine 7 and 8 to get this. But it would be one pair is both parallel and congruent. Or the last one is that the diagonals would have to bisect each other. Oops, that's not done very well. So 1 tick mark, 1 tick mark, 2 tick marks, 2 tick marks. Okay. All right. Now, these are the main reasons right here. And let me do this. Let me shrink it down just a little bit. And then I'm going to cut and paste some stuff here. I'm going to take these 10 things and I will copy them. Okay. So now if you actually look at the second page here, these are some very common terms that we'll be using in this unit. Okay, so if you ever get lost on what the most basic definitions are for some things, you can come over here and reference them. Okay, so let's take a look at the next page, the Unit 5A notes. And then let me full page view. I'm going to paste that picture over here that we just had and reference that once in a while. So let me shrink that down. We'll just keep it as a reference over here. Okay, so the first one says prove that if you have the opposite sides congruent, then you get a parallelogram. But avoid using this reason in the proof. Instead, what we're going to do is use definition of parallelogram, which is the first one right here. Right? We're going to prove that you can get arrows, the parallel left and right, parallel top and bottom. That'll get us parallelogram. So that really you can kind of think of it like this. Prove that if you're given AB is congruent to CD and BC is congruent to AD, prove that you get a parallelogram. So the big shape is a parallelogram. And use reason number 1. Like that. Okay, now I'll tell you right off the bat, this is going to be a long proof. It ends up being 9 steps, the way that we'll do it. And so that if you know it's 9 steps, you know the last step, the 9th step, will be ABCD is a parallelogram. And we're trying to use this reason to do it. Okay, that's our goal. So let's start out with some of the givens. AB is congruent to CD, it's given. And BC is congruent to AD, is given. So right off the bat, we got this is congruent to this. This one is congruent to that one. Now, if you actually look at it, that is reason number 2. So if I didn't restrict what reasons you're allowed to use, we'd be done. The next step would be ABCD is a parallelogram because of reason number 2. But we have to avoid using that one. So the hint here is that for step 3 is that we're going to build this off of the previous unit, which dealt largely with congruent triangles. So in order to get some congruent triangles, I'm going to draw in a diagonal, like BD right there. And BD is congruent to itself. And if I put those 3 tick marks on it, now I've got SSS for my 2 triangles that I've formed. So let's do BD is congruent to itself. That's reflexive. And now I can say that triangle, like if I call the first one ABD, so ABD went along the 1 tick mark and then the 3 tick marks. So then the other one would be CDB. And my reason for the congruent triangles would be SSS. So there's kind of one big chunk of the proof. Actually, it's probably better to think of it as almost the first 2 chunks. These matched up the sides. There are my congruent triangles. And most people will remember that CPCTC typically follows congruent triangles. Okay, so we're going to match up some stuff in order to help us eventually get these parallel lines that we need. Okay, so let me color it. I'll use green. So for step 5, I want to match up parts of the triangles. And in order to get these parallel lines, let's say on the top and bottom, some of the pieces that I can match up would be like this angle here and this angle here. And those match up because the triangles are congruent. They're both between the 2 tick mark and 3 tick mark sides. So these are corresponding parts of congruent triangles, so they're congruent. So I'll number them. Let's do 1 here, 2 here, 3 here, 4 there. So angle 2 is going to be congruent to angle 3 because of CPCTC. Okay, and since 2 and 3 are the same, if you look at it, here's my Z shape. So right now, I can say, since 2 and 3 are the same, that the top and the bottom are parallel to each other. So I can say BC is parallel to AD because alternate interior angles that are congruent give me parallel lines. Okay, now we're going to do the same sort of thing with angles 1 and 4 instead. So if I go with angle 1 and angle 4, angle 1 is congruent to angle 4. Well, the reason for that is, well, the two triangles are congruent, and angle 1 is between 1 tick mark and 3 tick marks. Angle 4 is between 1 tick mark and 3 tick marks. So they're corresponding parts of congruent triangles, so they're congruent. And then now that I know that 1 and 4 are the same, here's this slanted Z, this sideways Z. So that helps me prove that this and this are parallel, because 1 and 4 are alternate interior angles that are congruent. So I can say AB is parallel to CD because alternate interior angles that are congruent give me parallel lines. So if you actually look at step 6 and step 8, step 6 gave me these parallels, and step 8 gave me the left and right parallels, and so now I can finish the proof with step 9 here. Okay? Let's take a look at the next problem. So I'm going to move this down so we can reference it again. Okay. So in this one, let's see. We know that 1 and 2 are the same. So we'll just start off with the given. Angle 1 is congruent to angle 2. That's given. And then I'll mark them in the picture. 1 goes with 2. And then the other given is that NCKY is a parallelogram. That's also given. Okay, so that means that the big shape here, this whole shape, I'll highlight it. This shape is guaranteed to be a parallelogram. And that's nice because if we already have a parallelogram, all of these things are true, right? So then it's just a matter of picking and choosing which ones are going to be most helpful. Okay, now the hint is that we're going to aim to prove that this triangle right here and this triangle right here are congruent. So in order to do it, we're going to match up some sides and angles of the triangles using the properties of the big parallelogram. So one of the things we could match up between the triangle on the left and the triangle on the right using parallelogram properties would be like, let's look at number 7 here. If you have a parallelogram, opposite sides are congruent. That'll help me say that this side equals that side, which is useful because they're parts of those two triangles. So step 3, I'm going to say MY is congruent to KC. And the reason is I have a parallelogram now from step 2, so I know opposite sides are congruent. Okay, so what I have right now is I've got an angle matched up and I've got a pair of sides matched up. Another thing I could match up between the two triangles would be this angle down here and this angle up here. Well, that's reason number 8. Right? I have a parallelogram, so I know those opposite angles have to match up. So I'm going to say angle M is congruent to angle K. That's because I have a parallelogram, so opposite angles match up. Okay, and now if you look at the two triangles, here's another A. I have angle side angle and angle side angle in both triangles. So now I can write triangle MYI. So if I call the first one MYI, it went 2 tick marks to 1 tick mark to no tick marks. So that would match up with KCE. And it's because of angle side angle. And then we know that anytime you have congruent triangles, you're pretty much going to follow it up with CPCTC to match up other parts of the triangles. Well, if you look at this, MI is part of the first triangle, and KE is its matching part in the second triangle. So that's actually our step right here. MI is congruent to KE. And then that's it. There we go. Okay. Let's take a look at number 3. So again, I will move this down. So here's number 3. Okay. We're trying to figure out if this thing is a parallelogram or not, or each of these. So in A, notice the 41s are the same. So these guys are congruent. And then the 22s are the same, so those guys are congruent. And if you actually look at it, that's enough to say that this thing has to be a parallelogram because of reason number 2. So this one is yes, because we have both pairs of opposite sides are congruent, so we get a parallelogram. Okay. If we look at part B, I know that this part of the diagonal equals that part. So let me highlight those tick marks. I know that this side equals that side. Other stuff we could match up would be like this vertical angle and that vertical angle, this one and this one. And then I don't know if we can do anything else. Some people like to say that this triangle and this triangle are congruent, but the problem is we have SSA, which is not a valid way of proving triangles are congruent. So this one, there's just not enough information. Because what we currently have is everything we can determine, but it doesn't match any of these ways of getting a parallelogram. Okay, part C. So in C, everything's 90. This is actually a rectangle when all the angles are the same. And if you think about the ways to get parallelograms, the only thing we know are the angles. So this is the only one that deals exclusively with angles. And then we just check, are the top left and bottom right, are these opposite angles congruent? Well, yeah, these are both 90. And then separately, are the other pair congruent? Yeah, these are both 90. So that's good. That's enough to say, yes, it's a parallelogram because this angle equaled that angle, and this angle equaled that angle. And so that gives us a parallelogram. Notice, even though these have different types of curves on them, 1 curve and 2 curve, it still meets the property. This still meets the property that this one is trying to say, right? The opposite angles are congruent. And then in D, we've got the 19s. So these guys are congruent because they're the same length. And then if you notice these angles here, you can make a Z shape using those angles. They're alternate interiors, and they're congruent, so that makes these lines parallel. So now what I've got is congruent and parallel. One pair of opposite sides are both congruent and parallel. That's reason number 4. So this one would be yes, because we have this property. Okay, so that's 3. Let's take a little bit of a break from some of those, and we'll look at number 4, and it says draw a triangle. And I'm going to try and draw a triangle that's not really a special type of triangle. I don't want to draw one that's like perfect like that. Instead, I'm going to draw one like a short side, a long side, and a medium side like that. Make that a little bit straighter. I don't know if that's any straighter, but whatever, you get the idea. And then we're going to pick 2 sides and find the midpoints. So let's say that here's the midpoint of one, and roughly here's the midpoint of the other. And then I'll call it M and N in this case. And so since M's the midpoint, this side equals that side. Since N's the midpoint of the bottom, this side and this side are the same. And then we're going to connect. And that thing where I connect them is called the mid-segment. Mid-segment of the triangle. And the question is, how does this mid-segment compare to this side of the triangle, the side it doesn't touch? Okay. So we did this in class, and really we're not going to prove it, but most people were able to guess that the mid-segment and that third side are going to be parallel to each other, which is true. So one fact is the mid-segment is parallel to the third side of the triangle. And then the other thing, I asked people in class to measure how long their sides were. So if you measure the third side and got something like 8 centimeters, it turns out that the mid-segment is exactly half of that. It's 4 centimeters, right? So the mid-segment ends up being, mid-segment is half the length of the third side of the triangle. Okay. So now what we're going to do is we're going to use that idea in number 5. Okay. So you've got this kid, Carlo, and he has a triangle where BC is 1,000. AB is 2,000. And AC is 1,500. And let's see. Then what he does is he finds a couple midpoints and connects them. So this guy right here is a mid-segment, right? And then the idea is that he keeps this part of the triangle and throws away the rest. So he throws this out. And the question is, how long are the sides of triangle AMN there? Okay, well, if this is a mid-segment, MN's a mid-segment, then it's going to be half of the third side of the triangle, this side. So it would be half of 1,000, right? So let me do this. This is original sides here. So the original sides were 1,000, 1,500, and 2,000. And then what he did was he cut them in half, essentially. The 1,000 got cut in half. And I realize you can write 500, but I'm going to write it like this. 1,000 times 1/2. And then the 1,500, since n's the midpoint, AN is going to be half of 1,500, which is 750, but I'm going to write 1,500 times 1/2. And then there's the 2,000 that gets cut in half because m's the midpoint. So this side is just half of that, which is 1,000, or 2,000 times 1/2. Okay. So now at this point, he's got this triangle AMN. And then the idea is that he does the same sort of thing again, where he finds the midpoint here and the midpoint here, and he cuts it. And you're left with this little green triangle now. Whoop. Okay, well, really what you're going to do to get the sides of the green triangle are just cut the sides of that red triangle in half. So that means you take this length and multiply it by another half, this length and multiply it by another half, and this length and multiply it by another half. So like that first one would be 1,000 times 1/2 times another half, which you could write times 1/4, or you could write it like this, 1,000 times 1/2 squared. Okay, so I'm going to write it that way, 1,000 times 1/2 all squared. Same deal with the 1,500. That'll get cut in half twice, right? First cut, second cut. And then 2,000 times 1/2 squared. Now, if you did it again, you cut it right here, and then you'd have everything one more time, so you get cubed. And if you did it again, to the 4th and 5th and 6th. So notice after one cut, it's 1/2 to the first. After 2 cuts, it's 1/2 squared. After 6 cuts, it's just going to be 1,000, and then you're going to have it 6 times. So it'll be times 1/2 to the 6th. Oops, 1,500 times 1/2 to the 6th, and 2,000 times 1/2 to the 6th. Okay. So one more page here. So that's kind of a side note. We'll come back to mid-segment stuff later on in the unit, and I think it shows up somewhere in your homework. Let's go back to quadrilateral stuff now. So let's look at the rhombus here. So a rhombus, it's mentioned here, it has 4 congruent sides. All the sides are the same. And it says, prove that if you have a rhombus, then the diagonals are perpendicular to each other. So in this problem, we're going to say the given is that KMLJ is a rhombus. And the goal is to prove that MJ is congruent to, or not congruent, sorry, perpendicular to KL. Okay. So, first step is KMLJ is a rhombus. So that's given. Okay, and then the only thing you know about rhombuses is, so far, is that they have 4 congruent sides. So this equals this, equals this, equals that. So I'm going to write for step 2, KM is the same as ML is the same as LJ is the same as JK. And that's definition of a rhombus. Okay. Let me come back up here, and I'm going to bring this down too. So cut that, and we'll paste it down here. Okay, now, yeah, I don't expect you guys to necessarily come up with these on your own, but the next step is, one of the things we can say is, this is enough. So let me get rid of that for a second. This is enough to say that KMLJ is a parallelogram, right? Well, it's a parallelogram because of one of these reasons. These are how we get parallelograms. And if you think about it, it's reason number 2. The kind of top left is the same as the bottom right side, and the top right side is the same as the bottom left side. So both pairs of opposite sides are equal to each other. So I can write this. Gives me a parallelogram. Now it just so happens that this is a special case where all 4 of them happen to be equal. Okay, so now we got a parallelogram, and that's nice because now I know all these properties will apply. Okay, so let's put this back. So we have those diagonals in there, and it turns out one of these properties of parallelograms deals with diagonals. Well, the diagonals cut each other up. So in step 4, let's see, let's make up a letter for this middle point here. So let's just call it, I don't know, let's call it A. Okay. So I know that since the diagonals cut each other up, I know that MA has to equal AJ and KA has to equal AL. So MA is going to be congruent to AJ, and KA is going to be congruent to AL. And the reason for that, let's see, let me put the tick marks on here. 1, 2, 3, 1, 2, 3, is because of this reason down here. If I have a parallelogram, those diagonals bisect each other. Okay. So at this point, if you look at those 4 triangles that I formed, they're all identical to each other because they all have a 1 tick mark, a 2 tick mark, and a 3 tick mark side. So I can actually say that all 4 of those triangles are congruent because of SSS. So right here, if I call the top left triangle KAN, then I went along the 3, then the 2. So the next one would be LAN. And then if I went 3 and 2 for the bottom triangles, it'd be LAJ. And then KAJ2. Okay, and then after that, we're going to follow this up with CPCTC to match up some stuff. Now, if I'm trying to prove that the diagonals are perpendicular, I'm probably going to need to look at the angles in the center here, right? And it turns out that they're all between a 2 tick mark and 3 tick mark side. So these are all congruent angles down here. So I'll number them just so we don't have to use letters. So 1, 2, 3, 4. So they're all corresponding parts of these 4 congruent triangles. So I can say angle 1 is congruent to angle 2, is congruent to angle 3, is congruent to angle 4 because of CPCTC. So all 4 of these guys are now equal to each other. Now it turns out, if you notice, these guys are all formed by 2 lines. Okay. You could, I mean, theoretically, you could say, well, I know it's 360 degrees all the way around. Since they're all the same, I'll divide by 4 and I get 90. But in a proof, probably the quickest way to finish the proof is to say MJ is perpendicular to KL, and this goes back to unit 2. It's 2 lines forming these congruent angles that are all next to each other. So there's a theorem that we learned that said if 2 lines form congruent adjacent angles, then the lines are perpendicular. And then we're done. Okay, so now we can change these to right angles. Okay, now I'll tell you right off the bat that this proof does a lot more than just proves that the diagonals are congruent, or diagonals are perpendicular in a rhombus. But it actually, really the main feature of this is if you have a rhombus, so if you know all 4 sides are the same, and you cut it up, then not only do you get perpendiculars, right angles in the middle, but you get all 4 of these triangles are congruent to each other. And that's really the key, right? So if all 4 triangles are congruent to each other, this angle matches up with this angle, matches up with this angle, matches up with that angle. These angles all match up. These sides match up. And these sides match up. So you actually have a ton of nice symmetric properties here for a rhombus, as long as you know it's a rhombus. So let's come down to here. Yeah, and you even know that it's a parallelogram too, right? So let's come down here and do an actual like rhombus problem. So we've got a rhombus with diagonals of 10 and 15. So let me draw kind of a diamond-looking rhombus here. So right off the bat, since it's a rhombus, all 4 of these sides are congruent. And I know that one diagonal is 10, and the other diagonal is 15. And we just learned that if you have a rhombus, the diagonals are perpendicular. And we also learned that this side equals this side equals that side. That was all part of the proof that we just did. Well, if this equals this and the total's 10, then they got to be 5 and 5. And then similarly, since the whole thing going across here is 15, it's going to be 7.5 here and 7.5 there. And the goal is to get one of the sides, because all 4 sides are the same. So if I call that x, let's take a look at one of those triangles by themselves. It's 5, 7.5, and x. When we get x, we can use Pythag. Well, if you add these guys up, you get 81.25 equals x squared. And then if I take the square root, you get something just over 9, and it turns out to be about 9.014. And then these are all in inches, so this is inches. So that's approximately what x equals. Okay, and then that's it. I hope that clicks a little bit for you, and I'll see you guys soon.